Okay, so we have a question and we are going to determine its profit function. Now, reading the question, a monopolist faces a linear demand function of x equals 100 minus p, where x is demand or output and p is price. So first things first, I'm going to substitute q in for x just to make it a little bit easier to understand graphically. Plus q will stand for quantity or output. So right, q is equal to 100 minus p. Okay, and then putting that in terms of our inverse demand function, because we want to work in terms of our output. So we need that in the problem, right? We need that to be our independent variable, not our dependent variable. So another way you could write this is f of q, f of p is equal to 100 minus p, where f of p is equal to q, which means p is our independent variable. We want p is our dependent variable. So rearranging terms, subtracting q from both sides, adding p to both sides, p will equal 100 minus q. That is our inverse demand function. Now we want to find the profits for this monopoly. And profit minus total costs. Now I forgot to mention your cost function is 25q. In the problem it's 25x. Which you'll need that in order to solve for your profits. That's the marginal cost. So your marginal cost. And so supplementing p into our function here, which we have, and distributing, you're going to be left with 100q minus q squared minus 25q. And that right there is what your profit function is. So what do we do with that in order to find the maximum profit? Well, there's a couple ways you could go about it, but in order to solve it in terms of what we want, you could take the first order conditions of this profit function and set it equal to 0. So you're going to take your first order condition, which simply means take the first derivative. Which will equal 100 minus 2q minus 25. Combining like terms, set that equal to 0 always. You will get 75 minus 2q. Dividing through, by 2, you'll get Q equal to 37.5. That is the quantity that will maximize your profits. And so you will plug this back in to your profit function. So if you go 100 times, well, first you could actually combine like terms here. And you can plug it into that. But you could also find your profit by using the original profit function. So you have to solve for for P, sorry. And so P is going to equal 100 minus 37.5. Which will be 62.5. So that is your P. Plugging that in. Maximum profits will equal 62.5 times 37.5 minus 25 times 37.5. And you will end up with $1,406.25. So that is your profit function. Now you could plug that into your profit function up here, and you would get the same result. So if you were to write profits with respect to 37.5, it's 100 times 37.5 minus 37.5 squared minus 25 times 37.5, you would get the exact same answer. And so what do you do with that information, right? Well, you could graph it. Which I've done. And you could look at this crazy looking graph right now, where you have your x-axis is your Q, your y-axis is your profit, your revenue, and your costs. And you can derive some pretty interesting things, right? So cost function is 25Q. That's this linear line there. Total revenue is your downward facing parabola, the bigger one, and your profit function is your smaller downward facing parabola. Which is your 75, well, I wrote it in terms of X right there. It should be in terms of Q, sorry. 75Q minus Q squared, which we have derived from our profit function over here. And that disappeared. That's why it's a downward facing parabola, because of the negative Q squared. Same with the total revenue function. Now, if you look at your Q star of 37.5, which is what we have over here, 37.5, that will equal your profit function where the slope is equal to 0. And you will maximize your profits at that point, which will be $1,406, I believe, 25 cents. Now, you have to be aware that the profit, revenue, and costs are all graphed on this one plane. So the 875 is your revenue for that. And the profit is equal to that. So don't get them confused. Your profit isn't 1,875 if you produce 75 units, because that will drive your price down to 25. And you will actually make no profit at that point. So what is interesting about this, though, is at the point where Q is 37.5 and your revenue intersects there, and you take the derivative of your revenue curve, which is 25, it is equal to the slope. So taking the derivative of your revenue curve is your marginal revenue. At that slope, the marginal revenue is equal to 25, which is the same as your marginal cost. So the first derivative of your cost is 25. Your marginal revenue, put it in terms of derivative to keep it consistent, is 25. And a condition for your profit to be maximized is setting your marginal revenue equal to your marginal cost. And at that point, those slopes are the same. So you can prove maximizing profits by setting your derivative of your profit function equal to 0 by finding the profit function, or you can derive your marginal revenue from your total cost curve and your marginal cost, so your marginal revenue from your demand curve and your marginal cost from your total revenue curve, and set them equal. That will also give you the same answer. Now, this is a different interpretation. This is your quantity and price, where profit maximizing price was 62.5, gives you a quantity of 37.5, and intersects your marginal revenue and your marginal cost at 25. Now, this is a classic supply and demand. There's no supply though, so your supply is your cost function, which is a horizontal line at 25, because it's linear. But so I want to set marginal revenue equal to marginal cost. So your marginal revenue is the first derivative of your cost function, which is 25Q. Taking the first derivative of that, you will get 25. And I want to set that equal to the marginal revenue, which is the first derivative of your demand function. So you have your total revenue equal to price times quantity, 100 minus Q all through by Q. Distributing that, you get your total revenue function. Taking the first derivative of your total revenue function would be 100 minus 2Q. So you want to set these equal to each other. To maximize profits. Come on. So you will set 100 minus 2Q equal to 25 and solve for Q. So, adding 2Q to both sides and subtracting 25 from both sides. And we've already done this. So you will also get the same result, the maximizing quantity, when you set marginal revenue equal to marginal cost. That is one way of checking whether or not you have made a mistake or whether or not you have actually got the correct answer, through either deriving the profit function or setting marginal revenue equal to marginal cost, where your marginal revenue is equal to your marginal cost at this point, giving you a quantity of 37. And by equal, we mean that is the intersection point. Graphically, that's your intersection point. Where your marginal revenue is equal to your marginal cost. Marginal revenue, oh Jesus, is equal to your marginal cost. So, whether or not you're given both graphs or one graph, you should be able to derive the profit maximizing quantity. This over here, the 75, is just a demonstration of how making more revenue does not always equate to higher profits. making more revenue is detrimental at this point, where you have a revenue of 1875, but your costs outweigh your revenue is equal to your costs, total revenue, when you want your marginal revenue, which is the slope at this point.